Hello everyone and welcome back. So in this video, Lee is going to take a look at making the priority queue thread safe.
Right. Now, I don't know if we covered this in the intro, but if we didn't, I'm making up for it now, is the fact that this threading R&D isn't going to be the in-depth discussion of all things threading, as well as discussions of exactly what threading is, why we do it, and how to do it. And I mean, threading itself is a discussion that could be its own hundreds of hours long series.
I don't know about hundreds of hours, but it definitely could be its own standalone series giving an introduction to threading.
Oh, no, not just an introduction. I mean, covering all the topics and getting into GPU, multi-threading, and massive parallel programming and scientific stuff. All that really cool stuff you can do with threads. But that's well above and beyond the scope of this. What we're going to be doing here is making our priority queue work in a threading environment as is needed for Unity. Now, there are things that you can do in the threading world that are different than we're about to approach the issue. But those do not work inside of Unity. Things like mutexes and various other mechanisms for ensuring or preventing deadlocks and race conditions. What I have found with experimentation that the good old-fashioned lock is the most reliable way of working with preventing deadlocks inside of Unity with the least amount of headaches. So that's what we're going to be implementing. Now, the way this works is we take a section of code. So let's start off with, let's say, in queue. And we're going to look at any place that is going to be modifying our list collection. So in here where we're adding items and we're removing items from various lists, this is the type of code that we're going to want to prevent from being manipulated potentially in different threads or multiple threads simultaneously. So to ensure that, what we do is we call lock this, and we wrap that block of code inside of our curly braces. This will ensure that only one thread at any time can execute the code inside of this block, and will prevent a lot of problems. Now, that's not to say that it would prevent all problems. You can get into a condition where you've got multiple threads that are hitting these same methods at the same time, and then you get in a condition where this is always locked and your entire program comes to pretty much a screeching halt while it's waiting for things to free up. So in the case of the priority queue, doing this is not that big of a deal, because as we implement it with the train R&D and with the thread pool, there's only one other thread that's accessing this at a time, so it's not that big of a deal. Where it becomes a bigger issue is in things like once we spin off worker threads and we've got multiple worker threads that are all modifying things that need to be adding updates to a list to let things know what's going on. If you've got, let's say, 20 different threads, and those 20 threads could potentially all hit a list at the same time, and we use a lock, only one of those threads can enter inside of this lock at any given time. So as soon as one thread is inside of this lock, you could have the other 19 threads all sitting there waiting for this lock to get released. The moment it gets released, the very first lock that tries to enter then locks this block of code again, and then the next 19 threads have to sit there and spin while that one thread accesses it. So it can become a very difficult problem to try to solve. And unfortunately, with this very basic or primitive type of locking, it's an issue that we just have to kind of live with and be very careful in the way we approach our multi-threading to try to eliminate this. So what we'll do is we'll implement that same thing, again, any place where we're going to be modifying our collection. So around here, now inside of Peak, we don't have to worry about it because we're not adding or removing from our list. All we're doing is looking at an element, so that's fine. That doesn't hurt anything. Again, contains, all we're doing is looking at the list to see if something's happening. Inside of remove, we're modifying the collection itself. Therefore, it needs to be wrapped up inside of a lock. Oh, and something I should mention, if anybody's used to using mutexes, it's not so much that you can't use a mutex inside of Unity. They do work. Where they do become an issue, though, is inside of the web player. They don't work there. They'll explode. So I've just decided to not use them at all so that this functionality should continue to work inside of a web app as well.
Okay.
So just a little side note from, my early experimentations with it. So mutexes do work in some cases, not all cases, which also brings up another interesting little thing. This technique of multi-threading that I've verified works inside of Unity Editor up to a point where it explodes. Mm-hmm. It will work in the console reliably. It will work in a PC standalone build. And I believe I'll have to test again, but I'm pretty sure that this final solution also works in the web player. Mm-hmm. But I've not validated it on any of the Mac builds whatsoever.
Right.
So iPhone, iOS, Android. Well, Android's not really a Mac build, but iOS, Mac, standalone, Android, or any of the platform ones, this threading technique has not been tested. So I just want to head that off before people start posting and go, it doesn't work on my Mac. If it doesn't work, I apologize. So just letting you know.
All right. Well, with that pretty much wraps up everything for a priority queue. I mean, we now have a priority queue that we can use with the multi-threading system, but it's really time for us to start focusing on the creation of worker threads, thread pool, etc., right?
Yeah, and we've proven that this priority queue, while we're going to be using it for the threading system, mm-hmm. is completely standalone.
Right.
There is no threading system whatsoever, and we're using it right here. Mm-hmm. And I do want to show one other thing, though.
Okay.
Just to reiterate that this is generic in the fact that you can put anything in here that you want. It doesn't matter. So you could use integers if you wanted to. Helps if I finish up new queue integer. Oh, mm-hmm. Yeah, might help if I box that up. Yeah, I forgot. We did. this is a reference type. It's not a class because we did,
It's not a reference type. It needs to be a
or
reference type. Yeah,
yeah,
because you
it's a
constrained it
value
to a
type because
class.
I constrained it to a class. I forgot we did that. Yeah, righty, fine. That almost worked. Okay. Oh, that's not going to work either because I don't have Unity. All right. What? Man, why do I have to do that? All right. How can I do this?
Make a 2-second class, call
Yeah.
anything, and
And
what are you trying to do? Yeah, there you go. It's my box dent.
yeah, I'll get there.
All right, I'll be quiet. I'll be quiet.
I'm working on it. This is what happens when I go off the radar again. And hey, look, it worked. A little bit more in depth to just to prove my point, but yeah, it works. So it will take anything. You can actually put in classes, and we do some pretty weird stuff with it once we start getting into the thread pool and the worker threads. So we'll have some fun with it and some very shortly in these upcoming videos.
Well, what we are going to do, Lee, is we will actually take a break tonight now. Instead of
Mm-hmm.
starting right away on the worker threads next, because I know you've had about an 18, 19-hour day, and it looks like your programming skills may be diminishing at the moment with your exhaustion.
What are you talking about?
Nothing. So it might be a good time for you to just crash on out, and then tomorrow we can take a look at coding up the next stuff, which is where things start to get a little bit more fun.
Oh, it's not going to happen tomorrow.
Yeah.
I can't code on an airplane.
Yeah. Well, tomorrow or the day after. But right now, I think you definitely need to go ahead and get a little bit of sleep. But the priority queue is indeed working, and you've demonstrated that we can use it with pretty much anything, and that it's strongly typed, which is awesome. And the functionality that we need for the systems that we will be using it in is in place. And so with that, that is going to conclude this part of session 8 of R&D. Thanks a lot, everyone.